In this lesson, we're going to explore fact fluency. To do so, we'll be taking a look at what the Common Core authors have to say about it, both in the standards and in their companion document, the K-5 Operations and Algebraic Thinking Progressions. We'll also be looking at a research study that is cited in the Common Core references to gain more insight into what the intended meaning of the fluency expectations is. Standard 4 in the Operations and Algebraic Thinking domain specifies that children need to be fluent in adding and subtracting within 10, and that with the use of strategy, they should be able to add and subtract within 20. To understand this, we need to have some broader context. Does this mean, for example, that facts within 10 are to be learned by rote, but that facts beyond that, within 20, are to have strategies? Well, let's explore that through the use of some of these complementary documents. Not surprisingly, the Common Core authors use the expression fast and accurate to describe the fluency expectations in the Common Core. That definition is a pretty widespread interpretation of the term fluent, but it's still necessary to explore further. Often, fluency has been interpreted as being the result of rote memory. So what do the Common Core authors have to say about that? And what research are they using to justify their stance? I think with some deeper exploration, you'll find that the Common Core documents do not support rote memory as being the primary approach. In this quote from the Common Core Progressions, the authors specify that fluency includes, quote, just knowing some answers, end quote. But that could be because they've just worked with them for so long. For example, the facts that sum to 5 are ones that children have been working with since kindergarten. I mean, it makes sense that these facts will just be so familiar to children by the time they complete first grade that they know them without thinking because they've encountered them so many times. It doesn't necessarily mean that they've had flashcards or timed tests in order for that familiarity to develop. However, it is clear from this quote that fluency does not only mean that students just know without thinking. It also includes some answers from patterns and from the use of strategies. Here we see two more quotes. The top one is directly from the Common Core authors, and the second one is from Focus in Grade 2, Teaching with Curriculum Focal Points. The curriculum focal points are one of the documents that occur in the references section of the Common Core standards. There are two primary ideas that we're going to extend from these quotes as we tackle the subject of fact fluency. One is that it is a multi-year process. One of the grand advantages, perhaps the greatest advantage of the Common Core, is its focus on building a coherent developmental approach to building mathematical knowledge and skills across the grade levels. We will be looking at how fact fluency is to develop across kindergarten, first, and second grade, with our primary focus, of course, being on the role that first grade plays in that sequence. Both quotes here also describe a process of learning facts that uses underlying patterns, strategies, and mathematical reasoning, not rote memory. To accomplish this goal will require a shift in practice for a fairly large number of teachers. So to see why the Common Core authors have suggested such an approach, we're going to take a quick look at a research study that is listed in the references of the Common Core. The 1999 standards for the state of California required all basic addition facts to be mastered by the end of first grade. Now that's different than the recommendations by Common Core and NCTM, which place that benchmark at the end of second grade. So by the time we go through this particular research study, I think you'll have an idea of why that mastery benchmark was moved to the end of second grade. Now, the expectation with the California standards was not repeated at the end of second grade. So the way the sequence worked, the children were definitely expected to have it and have it by the end of first grade. That was the sort of do or die point. All children, mastery, end of first grade. Now, in the 2003-04 school year, Henry and Brown decided to investigate the teaching of basic facts in this really high-demand environment where all first-grade teachers were expected to emphasize that basic fact acquisition and to have it achieved by the end of the year. They wondered to what extent the children would be able to achieve that demand, or if the evidence might indicate that the expectation perhaps wasn't developmentally appropriate. They also recognized that there were two radically different perspectives that existed on basic facts acquisition, one of them being focused on memory and practice, and the other being focused on strategy development. They were curious about which of these approaches would be most beneficial, or if there was no statistically significant differences at all. So these research questions guided them. As they set up a research project, their research utilized 4 different school districts, which ranged everywhere from 3% to 94% economically disadvantaged, 8% to 92% English language learner population, and 1% to 87% white population. Very dramatically different kinds of school districts were involved. There were 275 students in the study and 28 different teachers. Here is a quote from the findings of that study. Quote, "More than 80% of the way through the first grade, only 6.9% of the students demonstrated adequate progress on California's basic facts standard by retrieving at least 80% of the facts. Even for students attending schools ranked academically by the state in the top 10%, achievement was far from proficient. Only 10.4% retrieved at least 80% of the facts." End quote. The addition facts acquisition was 40% and the subtraction facts acquisition was 12.5%. So neither set of facts was even close to the mandated expectation. Henry and Brown concluded that this data raised significant questions about the extent to which mastery of all of the facts within 20 was even appropriate for first grade. And of course, that expectation in California included both addition and subtraction. Heavy focus on flashcards, practice sheets, and timed tests also did not fare well in terms of fact acquisition by the end of first grade, even when the children were tested in ways that were consistent with the way they were being instructed. Referring to flashcards, practice sheets, and time tests, the authors state, quote, "In fact, none of these ubiquitous practice activities was found to provide a substantial contribution to memorization of fluency with the facts. Perhaps the most startling finding for teachers is that frequent use of time tests seem to actually work against student memorization and basic facts competence." End quote. The authors do go on to conclude, however, that they think first graders could achieve addition basic facts proficiency, but if the fluency was defined as a combination of derived fact strategies and retrieval from long-term memory, and if teachers were provided with curriculum and training that allowed them to foster a developmental sequence so that students could move out of their counting strategies to derived fact strategies. In fact, they found that the thing that prevented children the most from being able to get their fact knowledge was an over-reliance on counting as opposed to arithmetic strategies. So this particular research finding very much influenced the Common Core authors, I suspect, in terms of putting the benchmark at the end of second grade and also in terms of focusing on strategy development. And furthermore, the strategy development is a key portion of the algebraic thinking part of this domain. So strategies and patterns are essential in the fact fluency development sequence, and these strategies and patterns are introduced in the first grade. There is even a footnote in the 2.0A.2, so the second standard in the operations in algebraic thinking for second grade, and it references those mental strategies that were started in first grade and requests that they continue to be reinforced in the second grade. When we place kindergarten, first grade, and second grade Common Core standards for operations in algebraic thinking together, a multi-year developmental sequence for fact fluency begins to emerge. So let's take a look at that next. In the first row, we can see how the fact fluency expectations change with each year. And so you'll see that addition and subtraction within 5 is brought to fluency in kindergarten, within 10, first grade, and within 20, second grade. So we see that progression pretty nicely. The level 1 methods are supposed to characterize the kindergarten year, but that's not all. They're not just doing the direct modeling. The prerequisite competencies for those transitions to level 2 and 3 are also being developed at the same time. First grade is a linchpin year by which the children begin to coordinate those competencies so that they can actually develop those level 3 methods. Nevertheless, realistically, first graders will end the year at varying degrees of competence in employing these strategies fluently. You'll have some learners who are really not doing it very fluently, who have to be prompted to do it. You'll have other learners who are really taken off and are doing it very well, and you'll have some learners who do it for some kinds of facts but not others. So realistically, the end of first grade isn't going to completely do it for them, and that's why in second grade they are expected to continue with these level 3 methods, getting more and more students to use them more consistently. So this strategic development that you see outlined here is intrinsically involved in the development of algebraic thinking. It is through developing a mastery of these level 3 methods that children gain a deep understanding of the properties of operation. Many of the strategies work based on, let's say, the associative property and the commutative property. So these are principles that underlie them. They're generating equivalent expressions that are easier to solve than the original ones. Those are also very much in line with the algebraic thinking development. Here you see the facts up through 10 plus 10. The chart doesn't show the plus 0 facts, which children should experience, although those typically aren't really a major problem for children. The pattern with plus 0 relates to the identity property of addition, so that does need to be brought up in the curriculum. The color coding on this chart illustrates the various mental strategies that can be employed to actually reduce the amount of memorization. You can actually see that this entire chart can be reduced to just 4 strategies and then a pattern. Maybe 2 patterns if you count the plus 0 pattern. The green facts can be quickly solved by a count-on strategy, plus 1 or plus 2. Counting on by these small values is actually very efficient. The blue facts are doubles or near doubles. If they combine the doubles facts, which they should know really well, with the count on 1 strategy, then they can know even more facts. So you can turn a hard fact into an easier one. The red and the orange facts together relate to the make 10 strategy. The red ones are also make 10, it's just that it's like a sum of 10 plus 1. And the orange ones you have to do a little more decomposing. The make 10 strategy is one that we've talked about several times, and you'll see that it dominates quite a bit of the more difficult facts, and so therefore it's a very important fact for children to become skilled at. And finally, the yellow is simply a pattern that they started exploring in kindergarten of teen numbers as being a 10 and 1s, and then being able to work backwards, recognizing, for example, that 17 is 10 plus 7, but that 10 plus 7 is 17, and just kind of knowing that instantly when you see it. So that should be familiar to the children already. This is the same chart, but we have the kindergarten fluency expectations listed in gray. When the students arrive in your classroom, they are expected to already be fluent with those facts that sum to 5. In addition to that, Standard 3 under the Kindergarten Operations and Algebraic Thinking domain also requests that children have had experience decomposing the numbers up to 10, and the number in base 10 expectation for kindergarten specifies that they should have decomposed teen numbers into 10 and 1s and then recomposed 10 and 1s into teens. Now, the result of those particular kindergarten expectations that I just mentioned essentially ensures that children should have experienced the addition facts that you are to bring to fluency in first grade. They should have already experienced all those facts in kindergarten. You are just merely taking that fact knowledge and bringing it to fluency. Likewise, the remaining facts in this chart are to be brought to fluency in second grade, but the children are already to have expected to be working with them in first grade, developing some level 3 strategies. They may not be very fluent yet, but they're developing those strategies which can then be reinforced in second grade. You really see this sequence, multi-year sequence developing here. Now in this image, it's still the same chart we're thinking about. You see in the top corner the gray facts. Those show the facts that were brought to fluency during kindergarten. And now if you can see it, I have a set of facts that have a slightly darker black line around them, and those are the first grade facts for fluency. Those addition facts and their associated subtraction facts are the ones that you're going to work on. Really the only facts that don't have a particular strategy associated with them there are 5 plus 3 and 3 plus 5. A child could count on by 3. We've suggested that that's a possibility, but maybe you and your students might think about what strategy works best for you there. Now, we discussed counting on last week, but I want to revisit it briefly in light of the Henry and Brown study we just discussed. The researchers found that the children tended to rely too much on counting strategies rather than shifting to these strategies that are level 3, where we call it deriving a new fact, where they're converting it to an easier fact. However, counting on is highly inefficient if you're going to be adding a number larger than 3. So if the child feels under time pressure, it's also very error prone. So for example, 8 plus 6. If you start with 8 and you're going to count on 6, it's not very efficient. Then if you're under time pressure and you're trying to do it fast, it's also extremely error prone. So as children are developing these strategies, they really need a sort of rule of thumb that if you're going to be adding on anything more than 3, don't try to count it. Instead, use a level 3 method, which we don't use that term level 3. We might say use one of our class strategies, but don't count on. That would be a message that I would probably give them during the last half of the year rather than the first half, where I'm really trying to foster counting on. I also want to revisit one of the level 3 methods that we talked about last week, creating equivalent but easier or known sums. In the examples that I gave last week, I did not include a compensation example, but that is a strategy that should be developed in first grade, so I wanted to touch on that right here. So compensation also involves some decomposing and rearranging of quantities in your two add-ins, essentially to make the problem easier. So here I have 8 plus 6, and I would like to make it easier. It's one that I just showed you is not very efficient for counting on, so maybe it's something that our class is going to explore. What could we do with this? Because it's not an easy one to count on and do that well. In this case, if I sort of take 1 away from the 8 and give it to the 6, the entire problem converts to an easier sum, 7 plus 7. Now, if I try to show that with symbols, I'm going to lose some students. It's not, I mean, you can probably even see here the symbolic representation, 8 plus 6 equals 7 plus 7 with this minus 1 and plus 1 below it. Not very user-friendly for first graders. But the images which show this represented on a math rack are much easier. If I were doing this live, you would be able to see that as I take 1 away from the top row, I'm adding 1 to the bottom row. And it's the exact same amount that I had to begin with, but it's like taking 1 away from the 8 and giving it to the 6, and the whole thing turns into a 7 plus 7. When it's done in a concrete representation, it's much more obvious. Once students see it and they can articulate it and they can explain it, then we will go to a more abstract representation and study what that looks like and why it makes sense with the symbols as well as the concrete. Earlier in this lesson, we looked at how fluency expectations change over time, but the idea of a multi-year process doesn't merely involve just incremental expectations, like this grade you do up to the 5 facts and this grade you do up to the 10. There's a lot more to it than that. The entire process of acquiring fact knowledge, assuming that fact knowledge is going to be useful in long term, requires time. And that's why in kindergarten you're not only building the facts up to 5, you're also building the competencies that they will use at the first grade to do the deriving. At a recent conference, I saw an advertisement that stated that it guaranteed your learners would conquer their basic facts within 3 weeks. It is very clear that they have a very shallow interpretation of the word conquer. In order to be able to do the algebraic thinking aspects of strategy and arithmetic, then children have got to have a long-term fact knowledge where they're able to think about number and not just some song, for example, that puts it to music. You might think of fact acquisition as having several stages, although children are going to be at various places along this continuum. Ideally, the process is going to extend from kindergarten all the way through second grade, as we've talked about, and they truly need to make sense of the operation first. So a lot of what they're doing at kindergarten with acting out is really building this comprehension of exactly what's going on with addition and subtraction. You're also building visual models and representations that help them to make sense of number relationships. That's going to be critical in order for them to turn hard facts into easy ones. You also want them to have a set of really familiar anchor facts, and we're going to take a look at what anchor facts are most critical here in a moment. But those are the facts that they're going to use to derive facts, which is really what's happening in level 3. And then once they get to the point where they can create level 3 strategies, then they have to get faster at it. They won't be fast initially, but they can get faster after that's solidified. This exact same sequence also holds true when children eventually reach multiplication. In addition to direct modeling or acting out and visual representations that help children make sense, children are also, especially in that kindergarten year and then continuing on into first grade, they're becoming very skilled at decomposing and recomposing number. That starts in the kindergarten Common Core with Standard 3, and it continues in first grade with Standard 6 in the operations and algebraic thinking domain. The kinds of strategies that children develop, as you could see from that math rack example I showed you a moment ago, the strategies are heavily dependent on the visual images that we use. And so the dot cards, the math rack, the tens frames, we're going to really be using a lot of visual images. That will become very obvious to you in the next 2 lessons where we explore specific addition and subtraction strategies and some ideas about how we can get kids to construct these strategies. Not surprisingly, I think you're familiar with these already, but these are the anchor facts that are most useful for children who are going to be working with addition and subtraction and who we want to develop some level 3 strategies. The only thing I want to point out about this specifically is sums of 10. In the Henry and Brown study, they noticed that teachers taught count on, and they taught doubles and how to do a doubles plus 1 fact, but the teachers were less focused on the sums of 10. The authors recommended that much more work be done on that, given the fact that they are more versatile than the doubles facts. Start of year assessments can help you to determine the extent to which children have those prerequisite competencies for level 3 that we talked about in the last lesson. Following this, you should plan some interventions or extension activities that can either build those strategies for children who don't yet have them or reinforce those competencies for other learners who are getting them fresh in their mind again before they go into level 3 methods. Once the children have the anchor facts at their disposal, as well as those competencies like decomposing number, then they're going to be ready to turn those hard facts into easy facts. So that's where your focus will shift, is getting them to do that. And then once they have those hard facts, then we're going to focus on getting them faster at being able to put those strategies into action. And that stage is called building automaticity. You see a variety of techniques here for building automaticity. Those will be discussed in some of the upcoming lessons. The Henry and Brown research